Today, hello friends, hello students. Today we'll do Newton's second laws of motion. Newton second laws of motion. In previous classes, we just discussed a basic of Newton's first law. Now we did some derivations also. Now we'll just discuss the second law. Later on, I am telling you, we'll do some numericals that will consist of another 4 or 5 classes on this laws of motion, because unless until you are not clarifying your all the numerical problems, and you can't actually understand what is actually physics. What is actually physics? It is inherently coming. So you have to feel the scenario. Physics deals with nature. Okay. So now we'll start with the second law. After getting derivation of the first law, what Newton found, we previously discussed the momentum, we previously discussed the inertia. So the consistency is going on all the mass, momentum, inertia. So Newton thought some vacant places are there in this scenario. So he just generated new second law. The rate of change of momentum is directly proportional with the force applied on it. So what we have learned, the rate of change of momentum. So the rate and the change of momentum and directly proportional and force. So what the postulates from this particularly second laws of motion? First, what the rate of change, of momentum. This is the first one. Second, directly proportional is the mathematical part you have learned in class 9 or 10, whatever ratio and proportion part. Directly proportional. Third, the force. So from this we are getting what we previously did with the first law. One after one, we just what we got, we made a specification like this way. It will help you, though it's not mandatory to write like this way, but it will keep in your mind that the first part, the rate of change of momentum, next the directly proportional, third force. These are the thing. So the rate of change of momentum, previously what we got from the first law, the P is equal to mv. Now we have to make it the rate of change. So if as m is the fixed one, m is fixed, nothing to do with the m, keep it in mind. So and the rate of change of momentum, the rate you have to change with the what? The time. Obviously it will be with time. So m is fixed, nothing to do with the m part. So what we can change with the rate, if t tends to delta t, now starting with the delta 1, then we'll do the derivation part. So V will be from V plus delta V. It will changes. It will change like this. Once if T goes like this, in that span of V, as because M is fixed, nothing to do with M, mass is the very fixed one, mass will never change. Now we'll change. Now we have to derivation. So this P will change to delta P. After this, we have to do something with the calculus part. The limit. As T tends to delta T, but from the calculus, just I am wiping out this from this. You can copy it, so you can leave it. That's up to you. Now, if T tends to 0, so from that particular what we did it, P is equal to mv, P is equal to mv. So from P is equal to, so rate of change, so it will also change. So if we make the rate of change with the time, so it will be dp by dt. So from this part also, this is mv, so is equal to what? M dv by dt will get. So rate of change like this. So this dv, this is the main part of this overall. So dp by this one. So what is dv? Rate of change of velocity. We previously did rate of change of velocity. This dv by dt is nothing in algebraical form. Algebra, we this v2 minus v1. In calculus, we did it some like this way. This is algebraical, this is differentiation. So now what this part is nothing what we did previously by t, v2 minus v1 divided by t, rate of change of velocity. This is the thing. So this part ma, so it will be nothing but a, and this dp by dt is nothing but force. So these are the Newton's second law. From Newton's second law, we get F is equal to ma. This is very vital part. Okay, so this derivation is everything. This, if you go through the derivations, you can understand the second law properly.